EIGRP is Enhanced Interior Gateway Protocol. This protocol was Cisco proprietary until 2013, but please keep in mind that that's an industry standard now, which means that we can use this protocol in any vendor devices such as Alcatel, Huawei, and something like that. EIGRP is using the diffusing update algorithm to calculate the best routes and keeping backup routes also. EIGRP can also make equal and unequal load balancing, and you can summarize on each interface on EIGRP, where you can make the summarization just add ABR and ASPR on OSPF protocol. And EIGRP protocol is also using tables too, such as OSPF. We have three types of tables in here too. The first one is neighbor table, which includes all neighbors that's directly connected to the router using EIGRP, and that's the same thing in the OSPF. In topology table, EIGRP includes successor, feasible successor, and all other paths going to the target network. The difference in here with EIGRP and OSPF is using a feasible and feasible successor on the topology table, which provides faster convergence with the backup routes. Okay, and we also have routing table, and that's the same thing with OSPF2, which includes best paths for the target network. And we have 5 types of packets in EIGRP. The first packet is hello packet. Hello packet is used to discover the routers which are using in EIGRP. That's the same thing with the OSPF hello. And hello packets are sent to, oops, I wrote wrong, the 10, or if you are using IPv6, hello packets are sent to here as multicast for each 5 seconds defaultly. And we have an update packet. Update packets are sent if only there's a change in our network topology. And we have query packets. Query is the packet that asks if network occurs on our neighbor or not. For example, let's say that I lost some network and I need to ask my neighbor, hey man, do you have this network or not? That's the query packet easily. And the answer that my neighbor is telling me is the reply packet. That's the answer of the query packet. And we have the acknowledgement packet all in here too, and acknowledge the query update and the reply packets. And here is the formula of the EIGRP metric. There's a crazy formula, as you can see, that EIGRP metric is blah 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 blah. Really crazy formula, and this formula is known as the K-value formula. We have 5 K-values representing bandwidth, load, delay, reliability, and MTU. But by default, key 1 is equal to key 3, and they are 1. And K2 load is equal to K4 and K5, and they are 0. And in the end result, you can calculate the bandwidth with this formula. For example, when we check this example, 255 multiplied with 10 to the power 7 is divided to 64, which is the lowest bandwidth, as you can see in here, and plus all delays. All delays are 2000, 2000, 2000, and as you can see that it's 6000. And EIGRP is using diffusing update algorithm to calculate the best paths. And this algorithm is used by EIGRP to ensure that a given route is recalculated globally whenever it might cause a routing loop. And that provides a fast convergence too. We have two important terms. They are feasible distance and advertised distance. Feasible distance is the lowest metric for the particle destination. And advertised distance, which is known also as the reported distance, is the metric to a destination as advertised by a neighboring router. We are gonna examine these guys on our next slides. And we have also 2 important terms in here too, and they are successor and the feasible successor. Successor is the primary route that's used for reaching to a destination. And what feasible successor is, that's the next hop router that is guaranteed not to be a part of a routing loop for a particular destination. This condition is verified by testing the feasibility condition rule, which is advertised distance should be feasible smaller than the feasible distance of the successor. And here is the example of the dual algorithm. And we are going to check the feasible distance and advertised distance on our example. For this path, to reach this network, our feasible distance is 300 plus 10, and that's 310, as you can see. But the reported distance, I mean the advertised distance, which shows the distance of our neighbor, is 10. For this path, to reach this network, our feasible distance is 400 plus 10 and 410. But as you can hear too, reported distance will be 10 too. And because of 310 is smaller than 410, this route is the primary path for this router to reach to this network. Okay, smaller feasible distance is chosen first. And let's take a look at the Eigrp routing table entries. In OSPF, as you remember, we were seeing something like O, which means OSPF. But when we are using Eigrp, we are gonna see the D entry. D means Eigrp. Okay, as you can see that we learned this prefix with Eigrp because it's D, and here is the administrative distance of the protocol, and here is the feasible distance of the protocol. And we are learning this route via this IP, and this IP is our primary route to get the destination, and its name is successor. So let's check the Eigrp topology table now. As you can see that in topology table, we have some entries beginning with P. P means passive, which means that everything is okay. We are not actively searching another path to get to destination. Passive is good. Passive is cool. Don't forget it. If we are passive, it's okay. We don't have any problem. Let's take a look to the last route. For this route, we have a successor, and our successor's IP address is 35.5. Because we are using a feasible distance of 372 to get there, and here is the same value that we can see, which shows that this guy is the successor. So what about the feasible successor? The second guy. If I lose the connection, which is advertised by successor, the feasible successor handles the process, but there is a rule for that. And this rule is AD must be smaller than FD of the successor. And our advertised distance in here is this, and this value is smaller than the feasible distance of our successor. And that means that I can use this as a feasible successor. The first value in here represents the FD, and this represents the advertised distance in here. To configure Eigrp, we are using config router mode, and to get into the config router mode, we are typing router Eigrp and a number. Then we are using our network statements again, Then we can set a passive interface if we want to. Alright, this number represents the autonomous system number, and that was the process ID for the OSPF if you remember. And this number should be same for the other routers which are using Eigrp if we want to create a neighborship between them. And network statement in Eigrp enables Eigrp on the interfaces that matched with the IP address and the wildcard mask. Here is the difference. That automatically enables Eigrp on the interfaces. And as you know, passive interface enables the suppression of routing updates over some interfaces, while it allows updates to be exchanged normally over other interfaces. And to verify Eigrp configuration for IPv4, I'm using show IP protocols again. To verify the adjacency, we have show IP Eigrp neighbors command again, and we can also check our routing table